Hello and welcome to Recyclist. I'm your host, Eric Provost, and I am being joined today by a very special guest. Very excited to welcome this gentleman to the show right now. Please help me do that. The founder of Coviana, Mr. Pat Stanford. Thank you so much for joining me today, sir.
Thank you, Eric. I appreciate the invitation to be on the show.
Absolutely. Really excited to get into it. You are Mr. Leachate when it comes to subject matter experts. I really can't think of a better person to throw a bunch of these questions at. And I know that it's a massive problem affecting the industry. Really excited to get into it. But I just mentioned in your intro, you are the founder of Coviana. For those who might not be familiar, could you kind of explain the company for us, sir?
Sure. Coviana is the U.S. arm of the world's largest supplier of leachate treatment systems, with over 1,000 leachate treatment systems installed worldwide. Over 26 of those are actually ZLD, zero liquid discharge systems, where we're taking the water all the way to dry solids. And we have our first system being installed here in February 2026 into Upper Michigan.
Very nice, very nice. And this was a company that you founded back in 2002?
Yeah, Coviana was originally founded in 2002. It's been my side hustle for a number of years as I've been in and out of other things. But now I think we are permanently in place and moving forward with Coviana for the foreseeable future.
Well, I know that Coviana specializes in leachate treatment systems, and we're going to touch it. But you've had a very kind of interconnected, uh, you know, professional career with Coviana and even another company called Rokim, I believe.
Yes, I was with Rochem for a long time. I've been doing leachate for a very long time. We did our first pilot tests of reverse osmosis on landfill leachate in 1988. First permanent installations were installed about 1991. First permanent installation in the United States that I was involved with was 1994. So we've got a long time of experience going forward in terms of putting all of these back together. And companies tend to come and go. Rochem had been kind of a phoenix that they were sold several times and the original owners got them back every time. And came back pretty much every time that they did. So we're moving forward.
Well, the industrial landscape has changed just a little bit since the early '90s. New industries, new technologies, new a whole bunch of new stuff has popped up. But one thing that people are always going to say is there's always going to be trash. And with all these new industries, with all this new technology, trash has evolved quite a bit over the past few decades. And I'm interested to get into the weeds and talk to you a little bit about how that has happened, the problems that the industry is currently facing. I will say you and I had the opportunity to meet briefly last year at Archon up in Columbus.
Yes.
Did you have a good conference up there, sir?
Yes, it was a very good conference, very useful. One of the things that I got voluntold that I am now the uh, chairman of the SWANA's technical division subcommittee on landfill leachate and other liquids. So we're trying to help SWANA move forward in terms of putting all of that together. And then also as part of SWANA at Archon, we offered the third session of our class on PFAS in landfill leachate that talks about not only what PFAS is, but the different treatment options that are available and how that can help landfill and deal with all of the up and coming questions on PFAS.
Yeah, I know when it comes to SWANA's leachate program right now, you're basically spearheading it. That training program you spoke of, that was your baby, correct?
Yes. Yeah, I was the lead author and I'm the lead instructor for that class, and we are actually, I don't know if this will come out in time or not, but we're doing another session of this at GSWM in Indian Wells at the end of February.
Oh, very nice. I know that you've spoken at a lot of conferences over the years. You've been a SWANA member since I believe 2008, and you've spoken at other conferences like SOAR and stuff like that. What has been some of your biggest takeaways from those events, talking to a lot of the techs and a lot of the people on the ground and trying to help, guide your own systems and technical acumen, trying to help refine these systems for people? What have been some of the biggest takeaways for you?
Well, one of the biggest takeaways is that landfills are the end of the truck, right? So they end up taking whatever's coming on, and they really like the idea of having somebody else be end of the pipe and to not have to deal with leachate and just be able to take it to the sewer and not have to deal with it going forward. And historically, that's been the way. Out of about 1,800 landfills here in the United States today, there are probably less than 100 that have any sort of treatment, and probably less than 50, maybe less than 30, that have true treatment and not just pre-treatment before going to the sewer. And unfortunately, based on some of the new and upcoming components like PFAS, that's likely to not be an option for too much longer.
But I feel like I may be putting the horse before the carriage a little bit right now. Let's go ahead and kind of jump into leachate as a problem and potential solutions and a lot of the stuff that you guys are working on. A lot of the people who are going to listen to this, I'm sure, are at least somewhat familiar with leachate and the problems that it presents to the current waste industrial landscape. What is kind of the current state, in your opinion, of leachate? Because I'm sure it's evolved. I'm sure it's changed quite a bit from the leachate that you were helping with systems with in the early '90s. So I'm sure it was already incredibly toxic and dangerous back then. It's probably even more so today. Correct?
Yes and no. I would not call it toxic and dangerous.
Okay.
As long as you're handling it properly. It's basically 98% or more water. This is not Bhopal level of industrial toxicity that exposure to it's going to kill 10,000 people overnight. There might be some long-term health aspects that need to be concerned with on it. It needs to be properly handled, but it's not really a toxic issue for either the general public or the people that are working on it, but it is something that we want to deal with more closely. And leachate has changed a lot, but so has the trash that's coming in. I think that's the main reason it's changed, with all the green waste diversion that's taken place, all the recycling and removal of those materials out of the coming waste stream. The incoming waste streams have changed. That's changed the characteristics of the leachate a little bit, but it's still pretty much the same stuff, that it's coming in at 98 to 99.5% water, with some organics mixed into it, a little bit of heavy metals, a little bit of PFAS, a whole variety of things. And basically, anything that's coming out of a household is going to end up in the leachate. And let's go back even one more step. What is leachate? Well, any of the trash, any water that contacts the trash, whether it comes in with the trash, whether it's precipitation that comes in, whether it is uh, water that's generated in the biodegradation of the trash, all of that water is collected in the bottom of the liners of a subtitle D landfill, and that is called leachate. Leachate has to be properly handled under the subtitle D regulations.
And in terms of handling that, I know that those processes have also changed a bit over the years. But in terms of beginning to deal with that. You talk about a lot of the landfills that don't even have proper systems in place. Like, where do landfill techs and people who own these sites, what's ground level? What do they need to start thinking about? What are the considerations? Where does the plan start for leachate?
So historically, as I said, everyone would like to go to the sewer because they're the guys that are good with wastewater, and that's what their specialty is, not versus trash and going on. Uh, And historically, there have been a few components that might cause someone with a wastewater treatment plant to want to do it. It's not like the municipal sewage that's coming out of your household. It's more like an industrial wastewater, but it might have high organic content, high, normally referred to as BOD, biological organic oxygen demand. Um, and it might have high levels of ammonia, it might have high levels of heavy metals. All of those can impact the operation of the wastewater treatment plant because it's designed for the low levels of those things that come out of municipal household sewage. So you might have if you've got a big wastewater treatment plant and a small landfill, there's probably no problem at all. If you've got a big landfill and a small wastewater treatment plant, then there can certainly be issues on any of those things being allowed to be discharged to them. And then all of a sudden, the laboratory technologies have gotten much better. And compounds that 5 years ago or 10 years ago, we probably couldn't even measure to the levels they're now asking us to measure them to, such as PFAS.
Hmm.
Most of the compounds in leachate are being measured in parts per million or parts per billion concentrations, Whereas in landfill leachate and drinking water also, we're measuring PFAS in parts per trillion. So 1,000 times less than a parts per billion, a million times less than a part per million. So these are exceedingly low concentrations that we're looking at trying to measure on all of these things. If it wasn't for the lab technology getting so good, we would not have a PFAS problem today.
And in terms of the technology and the new measurements and instruments that are out there to help with that, what would you kind of recommend in terms of the most accurate ways that people can kind of go about? Because obviously a lot of this is federally regulated now, and a lot of this isn't even just an option anymore. These are mandatory. So, where like how do landfills, wastewater treatment plants go about finding these measurements?
Most of the PFAS measurements, anyhow, are going to have to be sent off-site to a lab. The technologies that are required for it are relatively expensive. They take relatively precise techniques to do it because you're measuring something that's in a part per trillion, which, as an idea, that's like one drop in 20 Olympic-sized swimming pools, or 1 centimeter between here and the moon. So it's a tiny fraction of a fraction of a fraction. So you only the best labs are really able to go through and do those sorts of things. This isn't something that you can go buy to the hardware store and buy a $99 handheld device and have it give you a good result in terms of what's going on. Whoever's doing all of your normal sampling can probably also help you with the PFAS analysis going forward.
If you need anybody though, shout out to Main Labs, friend of the show, Main Labs slash PFAS Laboratories. That's exactly what they do. So if you need something like that, give them a shout. But um, in terms of the treatment solutions that Coviana and yourself you're spearheading, what are those treatment options? What do those plans look like? What can people expect when they start working with you guys in terms of regulating their own, or I don't know if regulating may be the best word, but dealing with their own leachate issues?
Right. So historically, the traditional compounds, the heavy metals, the ammonia, the BOD, would typically be done with some sort of metal precipitation process on site, followed by a biological treatment process to go through, and that would be considered a pre-treatment process before going to the sewer. None of those processes really do anything to take out PFAS and the new emerging contaminants that are coming out. So you have to look at what else. In drinking water applications, something like activated carbon or ion exchange is a good option for dealing with PFAS. It doesn't work very well in leachate. All of the other organics in there compete for those absorption sites on those media. So you're not going to be able to just say, well, we're going to keep doing what we're doing and we're just going to throw a drum of carbon on the back end and that'll take care of it. So that's not going to be likely to be a good solution. Really, there are two steps in most PFAS systems that you're looking at today, that you're going to want to do a concentration step of some sort and then potentially do a destruction step after that. And the reason you do the concentration first is because the concentrations are so low and the cost of running a destruction technology is based on the number of gallons that you're going to be putting through it more than the concentrations that you're putting into it. So if you've got 50,000 gallons a day of leachate and you try and take that to PFAS destruction, it's going to cost you a lot. If you take that and run it through a pre-treatment step and squeeze it down from 50,000 gallons a day to 5,000 or 500 or 5, it's going to cost much less to do that pre-concentration. And then if you needed to do the destruction after that, you can go on. The two main technologies that are really appropriate for doing pre-concentration in leachate today are foam fractionation and, in my opinion, reverse osmosis. I'm definitely
Yeah.
biased because I am an RO guy, but we'll talk about those two.
Absolutely.
Foam
Yeah. We,
fractionation.
I know when it comes to leachate treatments, I know reverse osmosis is kind of a relatively recent but big buzzword. If you're talking about leachate treatment, you're probably very quickly going to hear the words reverse osmosis. And I know there's probably still a lot of questions around that. That's something at Diamond Scientific that we've spoken to several people about. And I think there may still be a few questions. And I'm glad you're here because I think you're the perfect person to answer them.
Good. I'll get to RO in a minute. Let me talk about foam fractionation
Of
first.
course.
So, if you'd come to me 5 years ago and said, would foam fractionation work to get down to parts per trillion in drinking water levels on PFAS, I would have bet my house and I would have lost it. Basically, foam fractionation is a process that's been around for 100 years, and it's been used a lot in the mining industry. It's been used in a lot of the food processing industry. And the idea is you bubble air up through a column of water, and those air bubbles collect some of the other compounds. Well, one of the compounds they happen to select very well is PFOA and PFOS, the two largest PFAS compounds out of the million plus that are out there. And those are the ones that have, to date, have been most highly regulated. So it will take it out very well out of landfill leachate. You can go through and do a 99.9% or more volume reduction on that. So you start out with 50,000 gallons a day of leachate again, and you can end up with 500 or 5 gallons of PFAS concentrate coming out of this foam fractionation process. And then you can either solidify that, stabilize it in some way, put it back in the landfill, or you can send it off site for a destruction process because you've got it down to a small enough volume to be able to go from there. But the hard problem with foam fractionation is that it doesn't handle all PFAS compounds the same. Works very well on the PFOA and the POFS, which have 8 carbon chains, carbon molecules in the backbone chain of the molecule. When you start getting to shorter chain compounds that have 6 or 4 or 5 carbon compounds in there, those are more water soluble. They're less likely to be entrained with the air bubbles. They're harder to take out. And all the foam fractionation manufacturers are working on developing additives that will go through and let you take all of those out well also. But there are so many versions of PFAS, and we don't know which ones are going to be regulated potentially in the future. So
That's a good point.
well, if you're looking for a solution that is good for today and would probably get you through the next 5 years, foam fractionation is great. It's going to go through and take care of the PFOA and PFOS, which are your issues today. However, if you are looking to try and be forward looking and say, I don't want to put in a multi-million-dollar system to handle today's problem and maybe have to either scrap that or add at least as big of a system afterwards to do the other things in the future, then you need to look at a different technology. And in my mind, the best technology to do that is reverse osmosis. You could also do a thermal evaporation type process to go through and be able to do that. Reverse osmosis is a process that was originally developed back in the 70s to desalinate seawater to make drinking water out of it. So it's designed from day one to go through and take salts out of water. Most of the things that are in leachate are salts or organic compounds.
Salts,
Um,
really?
yes. All right, you've got sodium chloride, you've got heavy metals are all in there as dissolved salts because they're all ions. And so you're going to have an anion and a cation. That's kind of what makes them into a salt. So you might not think of it, but you've got calcium chloride, or you have vanadium, heavy metal, plus chloride, or potassium, uh, and other compounds that will all go through and all are in a chemistry definition, they're all salts that are dissolved in the water.
Hmm.
And then you've got all sorts of organics. Now, a lot of it is humic acid type compounds, but lots of variety in there also, thousands of different compounds on the organic side that go through. Reverse osmosis, because it is a very tight membrane that will keep those very tiny salt molecules from passing through, also does a very good job on almost all of the organics to be able to go through at the same time. So a reverse osmosis system can basically take out 99.9% of everything that's in your leachate. The problem is it's a concentration process, and you're going to go through and you're going to concentrate that from 5,000 parts per million to 50,000 or 100,000. But that means you're still going to have 5 to 10% of the original volume, probably less. So if you're starting with 50,000 gallons a day, you might get to 5,000 gallons a day. You're not going to get to the 5 gallons a day that the foam fractionation system could do for you. So that, what do you do with that residual is now the biggest question in a reverse osmosis system. One of the reasons that I'm doing reverse osmosis systems on landfills is because most landfills are permitted to recirculate. So that all we've done is take out the only thing that's in leachate that's not supposed to be in the landfill, which is the water. Everything else came in with the waste. It was put in the landfill, which was supposed to contain it for eternity. The water came in and is now trying to take this stuff out. So if we can take it, separate out clean water to discharge, take the residuals, put them back into the landfill, we've done the most environmentally sensitive thing you can do, which is maintain all of the waste at the source of the waste rather than take it and contaminate another facility.
And I know that obviously the water that you take out would not be potable. I certainly wouldn't recommend drinking it, but I know some places, I believe you said, use it to manage dust, or they actually use it for other problems. So not only they are managing the leachate, but they're actually creating byproducts on the back end that they can help fix other problems with. And I think that's pretty cool.
Right. The water coming out of the RO process is probably cleaner than the bottled water that you could go to the store and buy. It's on the close to the order of distilled water that you would buy in the store, typically someplace around 10 or 20 parts per million worth of total dissolved solids. The drinking water standard for total dissolved solids is about 500. But there's always the risk that there is something in the leachate that we don't aren't measuring that could be a problem, that there could be a virus in there that somehow gets through. So no, I would not recommend drinking the effluent that's coming out of these systems, but it is very, very pure. It's been used for dust control at a number of sites, been used for construction water if they need water in their quarry, for instance, to be able to go through and keep the dust down there and process the gravel properly. It's perfect water for that because it has no minerals in it, so it's not going to contaminate anything else. You're not going to end up with issues on it. And many cases, certainly in Pennsylvania, where they've got all of those mine contaminations, that you end up with water that's got so much iron in it, it's hard to use it for any type of good purpose because it's already so, even the local groundwater is so contaminated. This is a great alternative to that.
Yeah, and I spoke with a couple people at Diamond in terms of the system that you guys are offering, and they came up with a couple technical questions that I will present on their behalf. The system, I imagine, is a fixed system for reverse osmosis, correct?
Most of the systems are fixed sites. We have standard designs, though, that will fit inside 20-foot or 40-foot shipping containers, depending on the volume you require. In a lot of cases, I personally prefer to install it in a building because it just makes maintenance of the overall system that much easier to be able to get all the way around the system instead of only being able to access it from the center aisle. But we can do a variety of systems. Individual skid sizes range any place from 10,000 to 100,000 gallons a day. And then we can put multiple skids side by side to do whatever type of uh, additional capacity you might need.
Yeah, capacity was actually going to be another question in terms of how much it could handle per day, per hour, stuff like that. What were those numbers again, sir?
So individual skids will run up to about 100,000 gallons a day. So if you need 400,000, we would put 4 trains in parallel to be able to get the flow up to the desired flow rate.
They also had a question about pre-treatments, about anything that needs to be done to the leachate before it can go through the RO process. Is there anything like that that needs to happen?
So one of the things that I have not brought up yet that I need to is is a very large difference between the RO systems that are being sold specifically for landfill leachate
Hmm.
and ones that are being sold for traditional drinking water applications. Most of the RO industry, probably 99.8% of it, is designed for taking clean water and making it cleaner. Whether that's taking seawater and making drinking water, whether that's taking municipal water and making industrial ultra pure water for something like semiconductor manufacturing. Um, those systems work great, but they're not designed to handle the level of suspended solids and specifically the level of organics that are coming in. If you're trying to put one of those traditional RO systems in place, you're probably going to have a lot of problems with it, but you're going to have to, even after putting a lot of pretreatment. So normally before a standard RO, you would go through and want to put uh, filtration, maybe a precipitation step, maybe a biological treatment step, membrane bioreactor, uh, certainly an ultrafilter of some sort in there to take out all of the suspended solids and anything else that are going on. The problem is there's still going to be residual organics that come through those. They're not, right? There's BOD and COD, biological oxygen and chemical oxygen demand. Your COD is always higher, just a different way of measuring it. So there's always going to be organics that pass through that pretreatment. If you get it into a standard reverse osmosis system, you're going to get biofouling of that membrane relatively quickly and relatively short membrane lives. There are some companies, including mine, that have specialty modules that are designed as an open channel flow path on the feed side, so that when you do get fouling on the membrane, it can go through and be cleaned readily out of the module to give you a long membrane life going forward. So the systems that I'm offering typically have very minimal pretreatment on the front end. We'll do a very coarse strainer on the front end to make sure that we're not taking rocks and frogs and dropped wrenches into the system. We'll then go through a typically a sand filter, kind of like a big swimming pool filter to take out most of it that we can then backwash and maintain the life. And then a 10 micron cartridge filter on the front end. We'll also typically go through and adjust the pH down to about 6. And that does two benefits to us. Number one is it minimizes calcium carbonate scaling further down in the system. And then it also goes through and shifts the ammonia ionization curve. So ammonia likes to exist as a gas. At high pH, it's a gas, and gases are not removed by reverse osmosis membrane. If we bring the pH down to about 6, that converts about 99% of the ammonia into ammonium ion, which is now dissolved in water and that the RO membranes can take out. And since ammonia now is one of the big driving factors in the level of treatment that you need to do, that works very well in terms of what's going on. So you can end up with a really big water treatment plant, or you can pick the right technology and simplify the overall flow path that you have to go through to put the whole thing in place.
I like that. They also had a question about the pressure, internal pressure, I guess, of the system. I assume that's a big consideration.
Uh, yes and no. Depends on how you look at it. Everybody says, oh, it takes high pressure. High pressure can be dangerous, but we've got all sorts of controls on it in terms of making sure that we're not overpressuring the system. We're using high quality materials for all of the high pressure piping and everything else. The pressure of the water coming out of your tap at home is probably about 60 psi, pounds per square inch. The first stage of the reverse osmosis system we would normally put in place will typically operate between 800 and 1,000 psi, so about 10 to 15 times higher. The more pressure you apply, the less volume you would end up with in the residual. So at 1,000 psi, you can squeeze down to about 50,000 parts per million total dissolved solids. We also have another line of two other lines, actually, one that will run up to about 1,750 psi and one that'll run up to about 3,000 psi. So we can put those together, take the concentrate off of the first stage, run it through the next one at the higher pressure, squeeze the volume down even further so that we can get to a smaller volume of final residual and take all of that clean water, blend it together. And typically we would also take all of that clean water and pass it through a second membrane. So all of the water has gone through at least two sets of membranes before it's discharged.
Yeah. And I'm sure a lot of these are questions that you typically get from a lot of the end users and the people that you speak to. I know that this technology that you've been developing for over the course of years, one of the things you've said is you've spoken to a lot of the guys on the front lines of landfill leachate treatment to kind of help address their concerns and get their viewpoint on what they're seeing and how this system can be changed and affected. How much has that perspective really helped advance your guys' treatment systems and technologies?
It's helped a lot because we are very responsive to dealing with operators and we want to make sure that they're comfortable with it. But the technology is pretty self-sustaining. It doesn't take a huge understanding. You don't need a PhD in chemistry to be able to operate one of these systems. Most of the landfills, we have taken an equipment operator right off from the facility and trained them how to operate the system. And it's not like it's a full-time job. You don't need somebody there 24/7. This is one of the big facilities with two that I'm familiar with has two 40,000 gallon a day trains, and they say they need about 13 hours a week to operate the system. So that gives that operator 20 plus hours a week of time to do other things that are also required around the landfill.
I'm sure there are other questions that you wind up getting. What are some of kind of the big the big inquiries that you wind up getting about the system, about leachate in general, when you're training or when you're talking about reverse osmosis? What seem to be a lot of the more common concerns and confusions that people have?
Well, one of the biggest concerns everybody has is how hard is this going to be to operate? How often am I going to have to change the membranes? How much is it going to cost to run this? And all of
Yeah,
those
the
kind
cost is
of
always going to be one of the cost is always going to be one of the first questions, obviously. But yeah,
Yeah, cost, unfortunately, it's really hard to give a specific number because it is very site specific
Of
in
course.
terms of what the volume coming in is, what the discharge requirements that we're going to have to meet are in terms of putting everything together. But typically, as a ballpark operating cost, you can probably put in a reverse osmosis and have an operating cost of under 5 cents a gallon on the total system. That's not the capital, capital separate, but the operating cost all in operations, labor, membrane replacement, uh, maintenance, power, chemical requirements for cleaning, and pH adjustment, all in operating cost is someplace under 5 cents a gallon. In certain instances, it's going to be less than 2 cents a gallon, depending on where you're starting from and what you're trying to go to. So that operating cost is very much in line with the cost that a lot of people are paying right now just to haul to the sewer.
Yeah.
Um, but in terms of membrane life is probably one of the biggest concerns because you don't want to have to change the membranes out that often. We've seen typically we'd be willing to guarantee a 3-year membrane life on the leachate stage, 2 years on the high pressure stage, and we've seen customers who've had up to 7 years worth of membrane life. So it's pretty reliable.
Fair enough. Here, kind of toward the end of the conversation, I am curious. Coming into the beginning of your professional career, was leachate something that you kind of picked early on as like this is a problem that I want to help fix, or did you kind of just fall into the leachate problem fixing industry?
We kind of just fell into it. We did an early test in 1988 at a hazardous waste landfill out here in California that just had a problem that they needed dealt with. Uh, then and we actually we were based at that time as part of a European company based out of Germany, and Europe put very strong regulations on leachate at that time. So a lot of the development of the technology was done in Europe, and we've been bringing a lot of those developments to the United States and feeding back everything that we've learned to help them improve the technology that they were developing also. But no, I originally I went to school. I got a degree in electrical engineering, and I've been trying to learn chemistry on the fly for the last 40 years to figure out how to make all of this work. But I had completely fell into it. I thought I was going to be a radio and television engineer. I never expected that I was going to be a wastewater guy and PFAS guru.
Fair enough. In terms of the training that you're offering, spearheading that we spoke about through Swana, how can people find that and learn more about leachate? How can people get to that?
Probably the best way to get to that is through the swana.org website. And if you look at upcoming, and there's a training button on there that you can use to find out for information about where we've got classes scheduled and what's coming up.
Awesome. And in terms of reaching out to you and Coviana, if people are interested in beginning their own leachate treatment path, how can people reach out directly to you or your company, sir?
Best way to reach out to me would be Pat at Coviana, C-O-V as in Victor, I-A, N as in Nancy, A.com, or Coviana.com on the web. Will give you a good starting point and understanding of what we're doing. And we'd be more than happy to talk to anybody who's got a leachate problem or a PFAS problem and see what we can do to help you better understand the problem and what your options are.
Awesome. Well, Pat, I want to thank you once again for coming on and answering a lot of these questions about leachate and helping to instruct us on, kind of the path forward in terms of dealing with this. I know reverse osmosis is going to be a big buzzword around the industry for a long time. So thank you for answering some questions on that.
Absolutely. Thank you very much for having me, Eric. It's been a pleasure being with you today.
Well, thank you very much for saying that. And for all of you out there listening, once you check out Pat and Coviana and do a little bit of leachate training over at swana.org. Also make time to check out Diamond Scientific. You can reach them online at diamondsci.com. That's diamondsci.com. Or you can set up a personalized presentation just by calling 321 223 7500. Recyclist is, of course, a registered trademark of Diamond Scientific. They are your gas analysis experts. But once again, thank you for joining us for this week's episode of Recyclist and my amazing guest, Pat Stanford, the founder of Coviana. We will see you next time. Thank you for listening.